Okay, so today we're going to be finding angles in right angle triangles using our trig ratios. Yesterday we were finding sides. In this first example, we've been given triangle ABC, and you can see their angle B is 90 degrees. AC is 90 meters, AB is 40 meters, and we're looking for the magnitude of theta. So that's that angle here in A. Okay, find the magnitude of theta, and magnitude just means the size of theta. Okay, we're looking for an angle, so our answer is going to be in degrees. We must remember that. And we're going to follow steps that are similar to yesterday. So the first thing we do is we name the sides using the angle we've been given. Okay, so we've been given theta, or I should have said name the sides according to the angle you are looking for. Right, I'm looking for theta. So for theta, the 14 would be the adjacent, the 19 would be the hypotenuse, and this side here, BC, would be the opposite. Right, so name the sides for the angle you're looking for. Then you ask yourself, which two sides do I have? Alright, so in my diagram, I have been given the adjacent, which is AB, and I've been given AC, which is the hypotenuse. Okay, then you choose SOHCAHTOA, one of your trig ratios. Adjacent and hypotenuse, I'll be using cos. So we choose our trig ratio. Using the sides you have. Okay, and we decided it was going to be cos, and it's got to go with cos of theta because theta is the angle that I use to name the sides. So cos of theta is going to be cos adjacent over hypotenuse. Adjacent is 14, hypotenuse is 19. Right, then we're going to solve the equation. All right, to start with, I can cross these meters out because this is one term, top and bottom, so they would divide into each other. I'm wanting to find an angle, which means I need to get first my trig ratio alone, which it is, and then we need to move the cos. We need to undo it, so it's going to go to this side. Theta is going to be arc cos, and then we're going to have our 14 over 19. All right, so we're going to have to use our second function or our shift key, and then we're going to use the arc cos that is on top of the cos button. Okay, so make sure your calculator is in degrees. We always have to check that. And we're going to press shift cos. 14 over 19. And we're going to get 42,54 degrees. Right. Number 2. Again, we've been given a right angle triangle. We've been given AF and FB. Angle F is 90 degrees. Remember, we can only use these trig ratios in 90-degree triangles, so you have to make sure that you have a 90-degree angle in your triangle before you start trying to use your trig ratios. All right, we're looking for angle A to start with. So this is the angle I'm looking for. So we name the sides. For the angle you're looking for. All right, so for angle A, hypotenuse, opposite the right angle. The other side that touches the angle is the adjacent, and then you have the opposite. Okay, which two sides do you have? Okay, I have the opposite, FB, and I have the adjacent, FA. All right, so which trig ratio am I going to use? So Katoa. Okay, opposite and adjacent, I would be using tan. So tan of angle A, because that's the angle that I use to name the triangle, is going to be opposite over adjacent. All right, and then we're going to solve it. Right, again, it's a trig equation. We're looking for an angle, so we're going to have to undo the tan. So angle A is going to be arctan 23 over 20. And we end up with angle A is equal to, it's 48,990. I'm rounding to one decimal place according to the question. So that's going to make it 49 degrees to one decimal place. All right, so angle A is going to be 49 degrees. Okay, number 2, we're looking for angle B. We could use trig again. You just have to rename your sides because now you're using a different angle. Or the easiest thing to use is the sum of the angles in a triangle. You know that angle A plus F plus B is 180. So angle B is going to be 180 minus angle F plus angle A. So angle B is going to be 180 minus 139. 41 degrees. Okay, the third example uses both finding sides and angles. We are told that AD is perpendicular to BC. So there we go, AD is perpendicular to BC. So both of those angles would be 90 degrees. We are looking for AD, and then we're going to look for angle B. All right, so I have two right angle triangles in this figure. All right, the big triangle is not right angled, so you cannot work in the big triangle. There's no right angle at A. We can only work in triangles that have right angles. So I'm going to start by working in this triangle. We could use either triangle to find AD, but this ABD triangle only has one piece of information, so we're not going to be able to solve that triangle. We need to start in the triangle with the most information, which is a stripy yellow triangle, because there we have a side and an angle. All right, we check, is there a 90-degree angle? Yes, then we can use our trig to solve that triangle. All right, so we are looking for a side. So the first thing we do is we name our sides for your given angle. That was yesterday. All right, so I've been given 48. So in this triangle here, this would be the hypotenuse. This would be the adjacent side, DC, and AD, the side I'm looking for, would be the opposite. Which side do I want? I want AD, which is the opposite. And which side do I know? I know AC, which is the hypotenuse. Okay, so then we make our equation. What are we going to be using? O and H. So Katoa, which one has O and H? It's sine, so I have to use the sine of 48 degrees, because that's the one I used to name my angles, is equal to opposite, which is the side I'm looking for, AD, over my hypotenuse, which is 18. Right, yesterday we learned now we've got to solve this equation. Okay, this one, we have to get AD alone. AD is being divided by 18, so we're going to end up multiplying both sides by 18, so that can cancel, and you can get AD alone. So AD is going to end up being 18 times the sine of 48, and we end up with 13,38 units. Okay, it says to 2 decimals, so there we go, 13,38. All right, so this side here is 13,38 units. And now we're going to move on to number 2, find the size of angle B. All right, so if I'm working with angle B and I'm looking for that, I'm going to have to work in this right angle triangle now. And luckily, we've just worked this side out, so I can use it to help me. That common side belongs to both triangles. It will help me find angle B. Okay, so I'm looking for an angle. That was today's work. So what do? Name the sides for the angle you're looking for. Okay, and I'm looking for B, so this would be the opposite, this would be the adjacent, and this would be the hypotenuse. All right, then we ask which two sides do we have? Okay, what do I have? I have the opposite, and I have the adjacent. I've got this 12 here. So I have AD, which is O, and I have BD, which is A. So what am I going to be using? I'm going to be using tan, TOA, opposite and adjacent. So we choose our ratio. Which angle do we use to name the sides? Angle B. And it's going to be 13,38 over the 12. Opposite over adjacent. Again, well, now we're looking for an angle. So this tan must move to this side. So angle B is going to be arctan 13,38 over 12. Remember, you're using shift or second function, okay, to get arctan. And we end up with angle B being 48, comma, checking, we're going to 1 decimal place, so it's going to be 48, 1 degrees. So we can find sides that join triangles together as long as they're right angles triangles to help us to move from one triangle to another.